I'm not going to say much. I just want to just introduce James Turk. He's from the Sunlight Foundation. We're very lucky to have him here. And in fact, at this point in the course, just to maybe if there's some random people that are not in the course and they don't know what we're going through, the pain that you guys are going through. At this point in the course, we're working with APIs and scraping web data and starting to wrangle with that data and do things with it. So at this point, we're very lucky to have James talk to us, because this is especially something that he works with often. He does much more than that, and I'll let him talk about what he does specifically. But I just wanted to say thank you to James for joining us, and take it away. Yeah.
All right. Thanks. Thanks everyone for being here. So I'm just going to talk about what I've been working on for the past few years. As was mentioned, I work for an organization called Sunlight Foundation. This is kind of a clipped version of our mission statement. The part in bold is really the relevant part. We're committed to improving access to government information by making it available online and redefining public information as meaning online. If you've ever tried to get government information, especially at the local level or state level, things are really behind. We're talking about going down to an office that might be open 2 hours a week, where you have to walk in there, hand them your ID, and flip through a book, and you can take photos, but you can't take the book out of the room or something like that. There's a lot of that. We do a lot of work both on the policy side and on the technical side to actually help liberate some of this data and set an example for government. So my project in particular is a project called openstates.org. This is a project focused on the state legislative level. So what we're aiming to do is basically take all 50 states, or what we've done now is to take all 50 states' legislation, all the information on the votes, representatives, committee hearings, any other kind of meeting that's available online, or in nasty PDF formats and things like that, and make that all available in a common format with data downloads in a common format for all 50 states and an API. Is everyone in here kind of familiar with what an API is? I know you guys have done some lessons and things like that. All right, cool. So we make all that data available freely. The project formally kind of finished and launched in February of this year, and we have had all the data since March of 2012, but there's obviously a lot of cleanup and things like that, which is some of what I'm going to be talking about. And just to let you know how, a lot of people ask, are people really interested in getting this data? We get around 10 million API hits per month. And the site pulls in, the site's openstates.org, pulls in somewhere between 100,000 and 250,000 unique visitors a month. And those are mainly people that are, searching online. We beat most state websites. If you search for a state and then a bill number or something like that, we generally rank higher than them because their data is not as accessible as ours. So Google likes us more. What it took to get to this point is kind of what I'm going to be talking about today. All the code is open source. We're talking about why that is and kind of the benefits of that for any kind of even smaller scale data projects that you guys might be undertaking. And all the code's open source at the URL up there. It's taken about 4 years of work and 50 plus contributors, so it took a while, and it's a lot of Python. Has everybody in here at least seen a little bit of Python code? All right, cool. So Python's a pretty expressive language. 50,000 lines of Python is a lot of code. 50,000 lines of C might not be quite as much code because it takes a little bit more C to get stuff done, but 50,000 lines of Python is a lot. It's definitely one of the bigger Python projects I've ever worked on. And most people that have contributed to it are in the same boat. So just kind of to define the scope of the problem, 50 states, Washington, D.C., and Puerto Rico. That's a total of 102 legislative chambers. We kind of count in terms of chambers because in a lot of states, like New York, for instance, the House and Senate don't really talk to one another at all. They have completely separate websites, completely separate technology stacks. They might as well be two different states. The information total, though, is then spread across 143 websites because sometimes the parties will even have their own pages where we need to go to get information from. These numbers are current as of a couple days ago. It's 7,400 state legislators that we're collecting information on every night, basically. Actually, that bill number is a little low. I forgot to update that, but I believe that that's probably about double now because we've gone through a whole session since I wrote this slide. So probably a little over 500,000 bills that we're collecting and 2 million legislative actions. And most of these LIS sites were built in the 90s. I'll pull up a couple examples in a minute. So this presents us with some real world problems. And some of these problems are probably, even if you're not familiar with this type of data, they're probably familiar to other data sets that you're going to be working with. We have 100 different data sets that we're trying to reconcile into one. There's all sorts of irregularities, like how many votes does it take to pass? That can vary not only within a chamber, but it can vary based on a vote if it's an emergency vote or something like that. How many chambers? DC, Puerto Rico, and Nebraska are unicameral. All the other ones are bicameral. So with those three, the process is completely different. And so you end up with different data when you're actually doing your coding and things like that. And things like how are House and Senate versions reconciled? A lot of people assume that the 50 states operate like 50 little versions of Congress. Well, thankfully, now that Congress is shut down, that's fortunately not the case. They all have their own process. New England, the legislatures in New England often inherit kind of a much older style of parliamentary democracy, and they work a little bit differently than Western states. Alaska has 15 senators, just by definition, just by the nature of having 15 people in a room instead of 500 people in a room in New Hampshire, things are going to work quite a bit differently. So you're also dealing with unreliable sources. Turns out legislators or legislators can't spell their name correctly half the time. So we're bringing in data, we're scraping in data that says who voted on a bill, and there's a guy named Smith with 3 H's that voted on a bill. So it's like, how do we handle data like that? And I'm sure in any data set that you guys are dealing with, you're going to see problems like that. Maybe not quite as bad some of the time, hopefully, but you're going to see misentered data, incomplete data, or a really common one is you end up with 5 people named Jones, and 2 of them voted yes and 3 of them voted no. And how do we tell their constituents which one's which? Because all they wrote was 2 Joneses in this column, 3 Joneses in this column. So trying to reconcile some of that data. Also, if you guys have done a little bit of web scraping at this point, I understand depending on the sites that you're scraping from, you might notice that they're not always there. Maybe they go down every other hour. Maybe sometimes a request takes 1 second to come back, and sometimes a request takes 10 minutes to come back. Because a lot of times they're running on web servers that are sitting in like the Capitol basement that haven't been touched since 1994, unfortunately. So some of the sites are so slow that scraping at normal speed would take over a day, and sometimes the sites just randomly get redesigned. There's a change in power, and the Democrats come to power in a state and decide that they're going to redo the entire site. This, of course, breaks all of your scrapers if you've written any CSS select and stuff like that. I know you guys have been doing. They're going to change all the class names just arbitrarily because, well, they're in power now. So the best case when you're looking at data that you can collect from a government is a database that you can piece back together. You might wind up, when you're looking at a data set, you might wind up with something like a MySQL or Access database. I'm guessing everyone's done a little bit of dealing with some kind of database of some kind. So this is obviously as close as you're going to get to just having all their data. In some cases, you are just being given all their data. But in the average case, you're going to end up with HTML. You might also deal with some JavaScript, which if you haven't done scraping on a page that uses JavaScript, that can be pretty tricky. I'm going to see if I can pull this up. So this is Alabama's site. It's called Allison. It's beautiful. So if you want to change session, you would click up here in this top corner. Then you would click one of these sessions. Then it'll close, and then Allison will come up. And now you're not entirely clear what's happened. There's some grayed out links at the top where you're not really clear what's going on here. So you can click around. Now I can click a bill. I can enter HB1, get status. It's going to load for a second. If this actually works, I'm not sure how the Wi-Fi is or how their site is. Well, if this had loaded, what would have happened is that the links at the top that are currently grayed out that I can't click on, oh yeah, here we go. Now I click this button. Now how anyone would ever figure. Now you click this button, now nothing happened other than the fact that it turned blue. But if you're paying close attention at the top, these links turned white. So that's how you would get to the sponsors for HB1. So that's obviously all done via JavaScript, which when you've been doing web scraping, I'm guessing most of the time you've been dealing with HTML and things like that so far. But you'll deal with pages that are actually doing all this insane functionality. And what you'll need to do is actually sort of reverse engineer their process. This can be challenging, especially on a page that's as hard. I mean, this page is hard for humans to use. I don't have any idea how anyone would possibly understand how to use this page without like an hour of instruction, which is what I eventually got from someone in Alabama. But you wind up with, having to actually find out what their code is doing so that you can write code that sort of replicates that process. When you look at this, you'll notice that it's not HTML that you're used to looking at. It's actually just all JavaScript that's rendering out pieces of this page. And so you'll actually have to figure out like where things are being printed from and extract information that way. So that is not the worst case scenario. The worst case scenario by far is going to be PDFs. This document, if it will load, is every vote that has been taken in Nebraska in the last session. It is updated every time there's a vote, so that can be multiple times a day. There's never really an indication that it's been updated. You just have to download it and check if it's changed. And it's enormous, which is why it's taking so long to download. But basically, it is a textual description of what's happened in the vote. It will actually say, the following people voted aye on this motion. And they all just get appended to a really long running agenda, basically, of what's happened. And it can be up to 160 days long. And so as the session goes on, the way that we get data out can, the amount of time that it takes to get data out can get pretty extreme. You're also dealing with natural language at that point, which can become quite the challenge. Fortunately, we've developed some tools to do all this work, and some of this stuff is hopefully going to be useful to all of you for other projects. Like I mentioned before, everything that we do is open source. We're a government transparency organization, so just by nature that makes sense for us. But also for a project of this scale, which I'll touch on a little bit later, it makes sense to try to open as much of your code as you can. I think for any kind of data collection project where you're going to be publishing data, one of the most important things to consider is publishing the source to get that data right alongside of it. Because other people, this is the first time I'm going to say this, I'll probably say this 5 or 6 more times, but when you're getting data, even if you think it's just a data set that you're interested in, someone else is going to be interested in that data set. And you might have left part of that behind that you didn't want, but you can save someone down the road some time by publishing the code that you use to get that data or even clean up that data alongside your data. It's basically the equivalent of publishing, your process for an experiment or something like that. It's really vital to have that code right next to the data at all times. So if you're interested in doing some scraping, so these are kind of our main tools of the trade. We wrote a library called Scrapelib. What Scrapelib does is basically deal with getting web pages down off the internet. When you guys have done scraping before, what have you guys been using? URLlib, or what have you used?
Well, so far it's LXML, right?
Mm-hmm.
There's also the CSS select that I told you about, and then
Yep.
Beautiful Soup.
Mm-hmm.
But also we've been working with APIs with requests.
Okay, with requests. Okay, so if you've been using requests, and you've seen a little bit of that requests.get stuff, Scrapelib actually builds on top of requests. So if you're already familiar with requests, you can use Scrapelib almost the exact same way. But it adds a lot of functionality that normal, standard working web pages don't need. But if you're dealing with government web pages or any other kind of institution where the web pages are not reliable, where sometimes you get pages that are returned that are incomplete, for instance, and you have to re-get the page to get the complete page, which is something you'll see more and more as you deal with older and older servers. Anytime that you're trying to extract information from an unreliable source, Scrapelib has a lot of things built in. It has built-in retry support, so if a request fails because the server was unavailable for the 5-second window that you hit it in, it'll retry 10 seconds later and 20 seconds later up to whatever point you want it to. And you don't have to worry about coding all of that. So if you're interested in using Scrapelib, you can grab it from this link. I'll make sure that these slides are available to everyone, but also it's installable if you guys are using anything like pip or easy install, you can just pip or easy install scrapelib. I heard you guys already are using LXML, so I won't explain why that is so important, but suffice to say, all of this work that we do, all 50,000 lines of this, are really relying on LXML. So I know you guys have probably done just a little bit with LXML, but it's a tool that will take you from the most basic things through all of the most complex pages. There's really no limit to its power. It's not something that you have to like put away at some point and learn a better tool. It's a really great tool to have in your tool belt. But then you're going to run into data formats that are a little bit less familiar. You're going to run into RDF files and ODT files and MDB access files and Excel files and PDFs and things like that. One of the great things about using Python is that Python has so many amazing libraries to extract information from all of these different data types. Pretty much any time I encounter a data type that I've never encountered before, see a file extension I've just never seen before, I can search on PyPy, which is basically the list of all Python packages. You can just go to pypy.python.org and search for, MDB, and you'll find 6 or 7 awesome libraries for extracting information from an MDB. You don't have to write that yourself, the same way that you didn't have to write LXML yourself to get information off of an HTML page. There are so many tools out there. If you're not using Python, if you're using Ruby or Perl, those are in kind of the same boat. They have Ruby gems and CPAN, which are very similar. It's amazing what the weird data formats that people have spent their time developing really nice libraries for. Sometimes you're not going to have a ton of luck. Like PDF files are notoriously complex. PDF files in some cases are just a list of numbers indicating coordinates and a list of squiggles indicating shapes, not actually text in a file. It just comes out that way on your screen, but there's no way to extract that raw text because they're just actual like drawings of letters, which isn't going to mean much to you. So in some cases, you're going to find tools that aren't in Python. You might search online and you might find a Stack Exchange or something like that where someone's talking about how to use MDB tools or PDF to text, which are just command line tools. The cool thing is that you can use command line tools from within Python too, and I'll come back to that. So yeah, this is an example of using command line tools from inside of Python. So there's a tool called MDB export that takes this tool takes a MDB file, which is an access database, and dumps it out to CSV. Now, CSV files are relatively easy to read from within Python. So all that you need to do is, from Python, you can just use these tools. And so the trick here is just get creative. If the tool exists and it's in another language, figure out how to run it. If the tool exists and it's a command line tool, it's still possible to run it. The nice thing here is that if you do it this way, you won't need to manually, the alternative is when people manually are sitting there and copying and pasting data out of an Excel file or out of a PDF and pasting it in. But then every single time that you run your program, even if you make the tiniest change, you might need to go through that process again. So if you figure out the way, take the time to learn things like subprocess, popen, which this is admittedly a pretty scary looking slide. But basically what's going on here is you have a command line utility, MDB export, and you give it a DB name and a table name, and it exports a table. So subprocess.popen is a really annoying way of saying, just run this command and then give me a file that I can read from that would have the output of that command. So you just run MDB export and you give it the database name and the table name, and it'll go ahead and spit it out to a CSV file. You don't really have to understand everything that's going on with spit out subprocess pipe, but anytime that you need to spit stuff out to a file, this is kind of the recipe for it. So if you have something that you know how to do from the command line, or someone can show you how to do from the command line, this is how you'd automate it in Python so that it can just fit into the rest of your code.
That's an access extension, right? Access database?
Yeah. So this was an older example from an older copy of the site for this class, last time I gave this talk. But this is an example of kind of how scrapelib works. You guys have already seen LXML, so there's not a whole lot here, but it works a lot like request.get. It's just scrapelib.url open. But the trick here is that if this site had been down, this participants list had been down for some reason, then instead of just returning immediately, that line would have actually waited until it either had a response or it was sure that the site was actually down. It would have tried 5 or 6 times. And that, so there's no actual code to configure that. That's just all done by default. That all happens automatically without you asking it. You can configure it. You can set all sorts of crazy options if you need them. But by default, this will run up to 5 times and back off up to a minute and wait until it can make sure it gets the page. And if it gets something like an incomplete response, it'll know how to handle that, not just give you back broken HTML. So after you've got, you guys have done some scraping of data. After you have data, you have it, pulled down in whatever format. The next thing that you're going to need to consider is how to clean the data. And this is where you should basically learn from what I was saying before. There are all these tools that are out there that other people have built to pull data from all these different file types. But now it's time to start building tools, and a lot of you, I understand you're beginners, you think of yourselves as maybe not great programmers yet, but it doesn't matter, because if you are writing code that cleans up a data set, that code will be useful to someone else at some point. Like, it's almost impossible, or at least yourself down the line 6 months from now. So when you're writing code that does data munging or kind of cleaning up data, one of the important things to remember is to kind of take this pipeline approach. Instead of having one program or one function that does everything, that just cleans up all of your data, you could have a clean atmospheric survey 1998 data set, and that would be very specific. And that could be something that you need for yours. But it might also be doing tons of other things. Like I said, that method might be very fast. It could probably iterate over records. It could do the correct transformations to each one. Maybe each one needs to have regular characters cleaned up, duplicate rows removed, case normalized. But instead, if you write each of those functions individually, if you structure your programs like this, and maybe even bake some of that into libraries that you wind up using. So down here, I have kind of what's generally a better way to do it, because usually the speed of cleaning up the data isn't what's important. So if you clean regular characters, that's something you're going to use every single time that you run into a file that has all sorts of nasty characters in it you don't want. So if you write that function instead of clean atmospheric survey, that's going to get you a lot further. So going back to open states, we could have written a function per state that said, clean Oklahoma data, clean Nebraska data. But instead, we find the commonalities, and that makes large-scale projects like this possible, but it also makes small-scale projects reusable. It makes a little 100-line throwaway script that you write one day to clean up. Maybe you're scraping your local municipality's website to find a list of dog parks, and you just want that personally for yourself. Sure, that seems like something that you're going to write once, you're going to get that list of dog parks, and you're going to run, but 3 months from now, you're going to need to do the exact same thing, but this time for battery disposal sites. And it's very similar, but you want to change just a few things around. If you have all these cleanup portions done in kind of a pipeline approach, where you can think of it going from one step to the next, not just one monolithic structure, that's going to get you a lot further, and you're going to basically be able to, something like remove duplicate rows, you can write remove duplicate rows without having any idea what the data actually means. That can just check if 2 rows are equal, and if they are, remove them. And normalizing case, basically switching things from all uppercase or all lowercase to some sort of standard sentence case, that's a function that will be useful anytime that you want data to be ready for presentation. So you're going to end up with many functions and many programs. You're going to end up with, I'm not really sure what's getting cut off at the bottom here. Oh, it says you will have to make changes and do this again at the bottom. I don't know why that's cut off. But the point here is that when you end up with all these functions and all these programs, then all those times that you have to come back to that data set and you have to make a small change, maybe the first time you forgot to include, you were scraping all the representatives in City Hall, but you forgot to include their photos, and now 3 months later you want to include their photos because you want to make a little gallery on your page or something like that. You can just go back and tweak that instead of starting from scratch. And this is kind of the thing I've been alluding to from the beginning. When you publish your data, publish your code alongside of it. All these little steps mean that your code will be useful to other people. It's something that we've referred to as the myth of the throwaway scraper. I work in government transparency. I've been working at Sunlight for almost 7 years. And so many times we need one little data set from the government, and we say, well, this one's a throwaway. And even after 7 years, I've said that to myself once or twice. And it's never true. You always come back to that data set for some reason 2 years later. There's always a time that you're going to come back to a data set. So anytime you're writing a scraper, anytime you're cleaning up data, don't consider it throwaway. It's going to feel throwaway because scraper code is pretty much by definition some of the ugliest code that you can write. It's never going to be, unless you're dealing with a really well-designed website, it's never going to be elegant looking code. It's going to be doing weird tricks to do those little clicky things that I showed you on that Alabama site. So it's not going to be elegant code. You're going to be a little bit ashamed of it, but you shouldn't be. Like, scrapers have to be ugly because what they're dealing with is ugly. That's why they're scrapers. So there's a really good site worth checking out called ScraperWiki. It does this really well. It at least models this. If you're not going to use ScraperWiki, it's at least a really good proof of this concept. ScraperWiki allows you to write code in the browser and run it in the browser as well. And it actually stores the data set that was collected right next to the code. And the trick here is that if anyone's looking at the data set and they notice that there's a small problem, maybe you were splitting, you had the person's first name and last name in one string and you were splitting on the space to try to get it, but somebody had somebody's name was like Mary Beth something, so you're splitting the string wrong. Tiny little tweaks like that, it's really easy for them on ScraperWiki to just go and make a little change to your code and then rerun and update the data right alongside it. If you're publishing your data without your also if you're doing any kind of cleanup, it's really clear where the problem came from.
Do you keep a change log of what was there before, what's there after?
Yeah, in terms of code, you mean? Or in terms of data?
In terms of the data, well, probably both.
Yeah, both. So for code, yeah, there's lots of different ways to keep a change log of the code. Generally, version control, I don't know if you guys touched on version control. Oh yeah, so generally version control acts as a really good change log. And there's nothing saying that you can't check your data, assuming that's of reasonable size, right into version control alongside your code. That's not an uncommon thing to do. You can check them both in side by side, and then this version of the code made this version of the data, and you can kind of see those changes side by side. That's a pretty common technique. For the data, one of the nice things is if you're trying to figure out where a weird change got introduced, if you've got a change log of the code, the nice thing is you can reproduce, in theory, any version of the data. That's one of the nice things about having a change log of the code and storing them side by side, is whenever there is a problem, you can look at the code that generated that data and say, well, this problem was introduced in this revision. We can see what we added there. So, one of the big things here that this isn't just saving you time, but if you're not in some sort of situation, if you're doing this for personal use or you're doing this for some sort of place where you can publish your code online somewhere, go ahead and do it. Publish it on ScraperWiki, publish it on GitHub, publish it wherever you're comfortable with. Just put it on whatever website you're publishing the data on, even if that's just your personal web page. Because, again, it's really unlikely. We all like to think that we're special and we're the only people that want this data set, but it's really unlikely that you're the only person that wants that. That's, pretty much every time I scrape something personally, I find someone else that's either already tried to do it or wants to do it after me. And, you save them time, and you also kind of help build a culture of everyone, understanding that this is the right way to publish scraped data and scraped code. The other thing is that it's going to save the content provider. At OpenStates, one of the reasons that we went open source right from the start is that there are a lot of commercial publishers that are after this data. Lexus and Thomson and stuff like that. They're going after this data and they're writing their own scrapers. And the last thing that we wanted to do was to kind of get into an arms race where we were scraping and 20 other people were scraping, and eventually these sites that could barely handle the load of one scraper would all fall down underneath the increased load. If everyone can work on the same scraper together, there's no competitive advantage to anyone having a slightly better scraper. Everyone, will improve one another's scrapers, and then we can all run one time instead of 50 people running their 50 slightly different scrapers, or scrapers that they didn't even know existed. So that's another reason. Content providers, a lot of times they're not a big fan of scraping. They don't understand it very much. They think that it's accessing data in a way that's not meant to be accessed. I mean, it's the kind of thing that you could have been doing by copying and pasting information off their site, so you're not really doing anything wrong, but a lot of times content providers don't understand it because they think that it leads to increased load. Whereas if you go to the New Jersey website and you download their data once per night, then you save them from having 500 people going there all the time and downloading their data all the time. And eventually, the state of New Hampshire actually came around on this pretty pretty much full circle. They were initially really hesitant to embrace any sort of scraping, and then they realized that it was saving them a ton of money because fewer people were having to hit their site, and they were just going and getting the data elsewhere. So
is there any accepted etiquette on contacting content providers before you subscriptions?
yeah, it's a good idea. Exactly what you said is contacting them is probably the first thing that I'd recommend. Getting in, doing your best to get in touch. 9 times out of 10, you're going to be ignored. Of the remaining 1 time, probably half of those, you're going to be told that you can't do what you want to do. Unless it's like actually proprietary data, that's not true. I mean, if it's some kind of, like, a lot of times you'll hear, we've been told by states that we're not allowed to scrape their site, which is just patently false, and so we ignore that. Usually that's someone that doesn't really understand what that means. Trick there is use the word crawl, not scrape. Technically they mean different things, but if you say crawl, and you even say the phrase like crawl, like what Google does, then they're a little bit less afraid. It's the same, from a technical standpoint, there are minor differences where you're actually going after specific information. Crawling is honestly more labor intensive for their servers to handle, but they're a little bit more comfortable with it because they understand search engines. Yeah, I could tell you a dozen stories about people that have told me that I can't scrape. But yeah, contacting them, finding out, and just kind of using common sense. Like, if you know that you're, first of all, that's another thing that Scrapelib does. Scrapelib actually will build in rest periods where it backs off, and it actually by default I think will only hit a page once per second, and you can tweak all that. And that's something that's easy to build into your own scripts by just having short sleeps. But it's a good thing to do. Don't hit a page as fast as you can if you're going to be hitting it thousands of times, especially if you're going to be hitting it thousands of times every day. Also, try to pick a time when, if you do slightly decrease availability, like you make the site a little bit slower because you're doing 20,000 requests to get every single vote that's taken place. Do that at 2 in the morning. Let it run overnight. Don't do that during the workday when, because then you will have some person that works at that company will be trying to access their own website and it'll be slower than usual, and they'll call the IT department and ask why, and the IT department will pull up the logs and see that you're hitting them 10,000 times. Do it at 2 in the morning, no one's going to notice for most sites.
We have certain publishers that if you're just looking at 10 abstracts, 10 pages essentially, they'll shut you down.
Oof.
And consider you a crawler. So.
Yeah. Yeah. So you need to watch out about getting shut down. And yeah, it can turn into, like, when you're trying to get data, it can turn into a bit of an arms race, especially because some servers have automatic things where they will do detection and feel like you're hitting them too fast. In New York, for instance, if you hit the New York Senate's website more than, I think it's once every 3 seconds, they assume that you're some sort of evildoer and shut you off for 24 hours. So you have to kind of learn, a lot of those lessons you have to learn the hard way. Most of the time, though, getting in contact, unless you're actually doing something malicious, explaining that what you're doing, explaining that the data that you're collecting you're not trying to profit off of their data, you're trying to make it available for public good, or you're trying to build on top of it. Most people are pretty reasonable when you do get in touch with them. At Sunlight, we're a nonprofit, we're trying to publish government information so that people can build mobile apps and build on top of it. News organizations can access it. It's hard for them to say no to that, because then I talked about 10 million API hits a day. The bulk of those are from news outlets. And so the last thing they want is a news outlet writing a story about why they can't have Washington State's bills anymore or something like that. So if you can, if you're doing something that's kind of in the public good and you can leverage that to kind of get permission, that's also really useful. And then the final thing here, which is kind of the best case scenario back from the beginning, I mentioned at the beginning, if you can get SQL or you can get an API or something like that, you don't have to scrape. That's going to save you a ton of time. Sometimes they will, there's 2 ways that you can get that. There's kind of the carrot and the stick method. There's the carrot here is you show them that we've shown them by publishing all the state data, there's demand for it. a lot of times they say, well, no one wants this. No one wants all of our data. No one wants to be able to download every single vote. People are interested in one vote at a time, and we have 10 million API hits a day to prove them wrong. And so some states have actually started to figure out if it's possible for them to provide their own bulk access so that we can be more efficient, so that people that want to get the data directly from them can get that. And to show, and when you publish data and you publish it in a good way, you're setting an example for the content provider that, you know, that dog park data that maybe you scraped, maybe there was benefit. Maybe if they just provided a single Excel file that had all the addresses of all the dog parks, people wouldn't have to scrape their nasty HTML pages, and maybe they'll just go ahead and do that. The other one is kind of, you know, the inadvertent stick approach, which is that if this does start to create a problem where they're being constantly scraped by people, they're going to realize that if they just throw the data online and just put it out there, it's less of a hassle for them. We've seen this happen in states as well. Some states have been like, we're tired of getting scraped. It's frustrating for us because our site's really poorly designed, and so you have to hit like 5. You saw that in Alabama, we have to hit 5 or 6 pages just to get one bill sponsor. So you can imagine what an entire session might look like. We're tired of getting hit that much. It's really frustrating, even though, you know, even though we're being considerate of their resources, like you should be. You shouldn't intentionally provoke this, but even though that's happening, they're noticing increased load, they're noticing increased usage, and so sometimes they'll just go ahead and publish data just to get you off their back, and that's a great way to get data too. And like, the end goal here is, you know, to stop writing scrapers, obviously. Like if we can just download bulk data and we can just access APIs and things like that, everyone's a lot happier, and we can spend our time doing more interesting things. But ways to show them that that is, you know, is beneficial to them and is worth their time. Making sure that your data is published. When they see that someone bothered to scrape their data and then publish it, that might indicate to them that, oh wait, people might also just benefit if we started publishing it. Yeah, I touched on a lot of these kind of recommendations. Learn a language and its ecosystem. Like Python's my favorite language. It has, I think, one of the strongest ecosystems. Ruby and Perl have really strong ecosystems for scraping and for data collection and stuff like that. Other languages are great for some things, but I, for instance, would try to avoid writing a scraper in a language like C or Java. They're just not, they don't have the ecosystem that is really well designed for this, and they're also just going to be slower to develop in. If you're scraping frequently, make sure that you take the precautions that we talked about. Throttle yourself. Oh yeah, use caching. This is another thing that Scrapelib will do for you. But if you're just kind of messing around, save some offline copies of the page so that you don't have to grab it every single time you run a test version, because that will probably be where you find out where the rate limiting is. That's almost always where we find out where the rate limiting is if we're not caching, because you'll end up running your script 20 times as you make small tweaks to it, and then you'll instantly be blocked and you'll realize, oh, I ran that too frequently. Expect downtime and timeouts. And like I said, Scrapelib does all this for you, and it's free, so hopefully it will be beneficial to you guys. Also, when you're scraping, save data to an intermediate format. You might be doing some manipulation on it later, but first save the data that you're scraping. This kind of goes back to the earlier question of, do you have a change log? Save the data that's raw. Just save what you're getting, because then you can run your pipeline on it multiple times without having to rescrape. So just grab the data, even if it's horribly broken and ugly and they've spelled their last name wrong. Grab that data, pull it down into a CSV file or whatever format you're comfortable with, and then separately have a process where you convert that CSV file to a cleaned up CSV file or a cleaned up. And that way you can kind of run these out of band with one another. You can scrape once, spend the rest of your time working on the cleanup script, and then when you need to, you can link the two together and have it do the scrape and the import together. And another little tip that is another thing that we always learn the hard way is don't leave easy data behind. If you're scraping a table that has 6 columns and you're interested in columns 1 and 4, because that's the person's name and the person's phone number, and their fax number is in column 5, go ahead and grab their fax number. It's one more line of code. You will probably want something. There's a really good chance you're going to want it later. And if you don't grab it the first time when you're scraping the page, then you have to go and hit every single one of their pages again. It's easier just to pull it out the first time. It's not an additional request. So if there's data sitting there, no reason to leave it behind. Just ignore it until you need it. That will save you someone who's, as someone that's written 50,000 lines of scraper code, I can say that if I had done that, I probably would have written it twice as fast. So, like I said, this is kind of just recapping. Think of the data as going through a pipeline. Allows you to use intermediate data. This is stuff I all touched on. And yeah, keep that separate from collection code. Publish things side by side. Another thing to mention, if you're publishing the code and the data, it might make sense if you have a very specific cleanup process. If you're not just fixing their errors, but you're maybe tying it into some other data set that has IDs in another collection or something like that. Make sure that consider if it's useful for you to publish the original source data and your cleaned data set. That might make sense, because some people might not want the modifications that you made, so it might make sense to go ahead and do that for other people. Just kind of being a good neighbor. It's really nice when you can grab someone's raw data because you didn't want all the changes that they made. You just wanted the scraper itself. Try to explain what the license is on the data, because data that's just sitting out there without anyone explaining if it's public domain or if it's underneath some sort of Creative Commons license or if it's restricted for commercial use or whatever's going on with it, that can be really painful, because usually when you scrape data into like a CSV file or something like that and you can open it in Excel, you've lost all context, and it's really hard to know, am I allowed to use this data in my project? And so try to have that clear. I mean, otherwise you're going to get emails from people that find your data and are asking you. So just save yourself some time and confusion, and just publish that data. And sometimes you can't redistribute the data because of license terms, but the nice trick here is you can always redistribute the code and let people build their own data sets. So there's some data that comes from the Bureau of Labor Statistics that it actually is, there are government restrictions on redistribution, which is a rare thing, but they exist. But if you just publish the code, anybody that wants to can run that code, wait 10 minutes, and they have the data set that you weren't allowed to publish. So usually it's just as good if you can't publish the data, but try to publish that data alongside it so they at least get kind of a sample of what they're in for if they did run it. So that's it. I mean, now I'm happy to take questions and things like that. These slides and other resources that I mentioned are all written down here. So if you want to get access to those slides, that's the ugly short URL to get to them. And most of the resources I touched on are all online at github.com/sunlightlabs, either OpenStates or ScrapeLib. And you guys have already used LXML, so you don't need to find that one. So.
Did the PDF download?
Oh, that's a good question. Yeah. Yeah, here it is. So, yeah, it started January 9th. Okay, it's only 1,700 pages today, and they're adjourned. So, but you'll see. I mean, you're actually going to have every single time we need to get data. Now, if they just published vote pages, one HTML page per vote, that would have been much nicer. But instead, you're going to have to go through, find a bold heading that looks like this. And then you're going to have to go down and find something that looks like voting for the affirmative, and then you're going to scan all the names after that until you find something that says voting in the negative, and then you're going to scan all the names after that until you find something that says present and not voting. And this is going to be your process, and you're going to have to do it, on every single page in this entire document, checking if there are votes and votes split across pages. And sometimes legislative language changes slightly, and sometimes they spell the word affirmative wrong. There are things like that. So this is obviously the worst possible way to get and publish, or one of the worst possible ways to get and publish data. The worst possible way is where you have a hand-drawn image, which only happens in Kentucky and Massachusetts. So yeah. And in that case, a lot of times you're just going to have to resort to manual entry. I can't really offer you a good solution for that one if you run into that. But yeah, so the good news here is that, as ugly as this looks, if you run PDF to text on this, which is just a command line utility, you actually get text that is relatively easy to process. You get these names and they're kind of separated in a grid, and you just kind of have to look through it, and you have to write code that recognizes when it finds certain phrases and that all the names after that voted that way. But you're just dealing with text at that point and not a big ugly PDF. But that's the good news. Bad news is obviously that this takes 5 minutes to download, and you have to download it a couple times a day, and sometimes it disappears. So.
Questions? Yeah.
Yeah. So scrapers seem to be so tightly bound to the structure of the page that they're
they're processing, what sort of diagnostics might you have in place to make sure that the structure hasn't changed so much that the data is no longer?
Yeah, that's a really good question. So,
Can you repeat the question?
yeah, sure. So the question was basically, yeah, the scrapers are tied very closely to the structure of the page. If they change something as small as a class name, or they make the top of a page an H1 instead of an H2, that could potentially break your scraper. How do you go about dealing with that? The answer is that I would generally design my scrapers to break early and often. Don't risk getting bad data. Have them make strong assumptions. Have them make an assumption that there's an H1 at the top of the page that has a class name of this. Put a comment in there, hopefully, for yourself so that you understand what that was about. Yeah, comment your scrapers liberally. Like I mentioned, they're going to be really ugly, so write a lot of comments to remind yourself what the page looked like. It's not unusual to have like actual snippets of HTML that you copied off the page and be like, what we were doing is we were scraping like the third div inside of this, inside of this parent. So here's what it looks like on the page, and then when it changes on the page, you can look at the comment. But if you design your scrapers to break early and often, then you will have to fix your scrapers, because the next time you go to run it, it will fail. You'll have a big error and say, no H2 found. There was only any, and then you can look at the page and be like, oh, there's an H3 there now. The alternative is being too general, and a lot of times this is tempting. You can sit there and you can really try over-engineer a scraper and make it, and think about the changes that they might make to the page later. One, they'll surprise you. They'll always find new ways to break the page in ways you hadn't predicted. So it's not necessarily a good effort. But the other thing is that you might accidentally start just pulling in completely incorrect data at some point, and without realizing it, especially if you're pulling in so much data that there's not time for a manual review process. Which is in our case, when we're pulling in millions of actions on bills, we just can't look at most of them. We just have to trust that they're there. The other thing to do, if it's like an important data set that's large, is kind of a post, if they've changed the page in a subtle way that doesn't break your scraper, even if you were trying to make your scraper fail, so forcing the human to look at it when something goes wrong. The other thing that you can do if you have a large enough data set is just kind of run some basic analytics on it. For instance, we have all sorts of things. You can't make a lot of assumptions. We can't say there are only 2 political parties, because there are a lot more than 2 political parties that are represented in the states. But you can say, has the number of political parties changed by an order of magnitude since the last time we ran? So if there used to be 7 political parties in this data set, and now there are 70, maybe we're accidentally pulling in their last name field where we used to be pulling in a political party. So you can look for things like that, and that's usually something that I would do. The way that our pipeline actually works, we have a scrape pipeline that runs completely separately. It scrapes raw data down to disk. Then we take that raw data and we do a cleanup pipeline where we correct misspellings and fix all the problems. And that runs separately and writes data back to disk. So now we have kind of 2 phases where we can look at it and see where anything changed. But then we have a third step that I didn't really touch on here, which is probably only useful for larger projects, where we actually do that kind of analytics. And it can be really simple. I mean, it can be a for loop that goes through an Excel sheet and counts the number of fields and makes sure that's within a certain range. It can, another really good example of doing this is when you have multiple data sets that are supposed to match up. Just have a really quick script that goes through and prints out how many things didn't match between the 2 data sets. If you're doing something big enough that it's not subject to manual review, usually you're pulling from multiple sources. Check and see if you're pulling down 200 legislator names from this page. Also pull them down from one other page and make sure that 198 of them match. 2 of them probably aren't going to match because there's some sort of mismatch, but make sure that some threshold that you're willing to tolerate is there. But yeah, then it does require changes to the structure of your code when they change the page. One of the nice things about LXML, if you're using CSS Select or XPath, is that hopefully a lot of times it's really just going to be changing like one expression, or maybe a couple dozen expressions throughout your code, and not be like the overhaul of the entire thing. It's one of the really nice things about using those tools.
You said it's kind of funny that if you hit a site multiple times and they just kind of change and say, well, we give up, we're going to put a CSV file up, or are you seeing like changes in how government sites are, just starting to change and maybe work with you to make their data more accessible?
This isn't really a technical plug, but the best method that we have discovered, and I don't know how this will apply to each of your work, but the best method we've discovered to do that is, to the extent that's possible, publicly shame them. So,
Public shame.
yeah, we published a report card. We basically chose a few principles that are kind of vital to open government data. We say open government data, but this really applies to any sort of open data set that you're potentially dealing with. We define these terms in a blog post that I won't bore you with, but completeness, timeliness, ease of access, machine readability, standards, and permanence. We rated each state on this spectrum, so like a 0 meant a certain thing. Completeness, a 0 was actually an okay score, which is why somebody had a 0. The 0 was about as good as you could do unless you went above and beyond, which is kind of the way things normalized out for the curve. But timeliness, I think a 1 means that they published every day, and the 0 meant they published every week or something. I forget the exact thing. I think there's a breakdown somewhere else. But, and then these scores averaged out, and then we gave all the states. So, let's see, Massachusetts, it's beautiful, beautiful. This pretty quickly got us some phone calls. Turns out when you give people Fs, they don't like it, even if they deserve it. And so yeah, I mean, we got some states have improved their grade. We're going to redo the report card about a year after we did this 6 months ago. So about 6 months we'll redo the report card. We'll be a little bit stricter this time too, so that you won't be able to get the same grade by not having improved at all. It's kind of our hope, kind of push everyone up. So yeah, quite a few states saw this, and we got calls from, well, what happened is, in a lot of cases, IT departments got calls from irate legislators saying, what the hell is this? Why did our state get an F? Or a D, or whatever. And one state was, I forget, blanking on which one, was it Wisconsin? One state was really upset they got a B. I was like, we're never going to hear from an A or a B, like, we just won't hear from them, but we have to focus on just getting the worst. Even the A's need to improve. But one state was just outraged that they got an A. And I was like, that's great. I'll tell you how to get it. And so they were like, what do we do to get an A? And they're working on that. I mean, it's a slow process, and states don't have a lot of money, so it can take some time. Some of these things are really easy, though. Like, some of these things don't cost money at all. Actually, a lot of them, if done properly, don't cost money. But sometimes they're so locked into certain vendors that there's some tape that they have to go through. But you can kind of hover over some of them and see, like Alabama, for instance, which you guys saw their site, it has a -2. We had a bunch of volunteers look at it and kind of rank them. Alabama by far got the worst. No one could figure. We asked volunteers to do 3 basic tasks: find out who sponsored the first bill of the session, find out the last bill that passed, and something else. And nobody could do it in Alabama, not a single person. So you end up with stuff like that, and then we were invited to give testimony in Alabama on why their site was so terrible. So if you can drum up, I mean, if your project's of the nature where you can drum up attention, this might not be like get major media outlets and get state senators on board. This might be like get someone's boss on board. It might be a smaller thing, but I feel like the best solution there might be non-technical. It might be more of a political one or organizational one.
What is your experience with foreign government websites?
Foreign government? So that's not something that we've spent, not me personally, I've spent a ton of time on. I work with organizations that do work with foreign governments, mostly English-speaking ones, so it's kind of a skewed sample. Canada's provinces are definitely worse than the states, but they're also, my understanding of Canadian politics is Canadian provinces are quite a bit less important than state governments are, so they get less attention. Most federal governments are much better than, or most English-speaking federal governments that I know people that work with are much better. than our federal government, which right now some of the most important data that you can get from the government, you just can't get it all. So it's not that big of a surprise that our government fails in comparison to theirs. I don't know why it's necessary to take down an entire FTP server because the government shut down. But apparently it was a non-essential employee. And so, yeah, other foreign governments, I know that there is a lot of work in the EU around data standards. I'm not as kind of clued into that as some of my other colleagues are. If you're interested in that stuff, though, there are a lot of working groups around like e-government that's kind of the code word in Europe. Usually in the US we call it government transparency, and there they call it e-gov. There's a lot of really good stuff happening in Europe, and as far as the rest of the world, I'm really not that sure.
I work at the law library, so you don't
okay.
think I'm some kind of
No.
hacking.
Yeah.
And because I know some of my colleagues are very interested in trying to get more data from foreign government sites and stuff. So that's,
Yeah. Law is a really interesting problem. And we mostly deal with the kind of pre-law artifacts. But yeah, the law access is something that some of my colleagues care quite a bit about. I know it's a complex thing. Some states are asserting copyright and things like that.
Have you ever used Mechanical Turk to do some things?
Yeah, so Mechanical Turk is a tool. Is everyone familiar with Mechanical Turk?
Maybe not.
Mechanical Turk is a tool. It's part of Amazon's suite of web services, although it is kind of the human web service. It is a tool that is based on kind of handing tasks to people. People can sign up to be Mechanical Turk employees or something. I'm not sure what the term is, but yeah, Turkers. Family. But people can sign up and then basically do very small tasks. Like you're shown a picture and you're like, is this person smiling or frowning? That's an example of a task that I've seen. And then they can categorize things that computers aren't necessarily great at, but people can do very quickly, and you're paid like 10 cents per 10 tasks or something like that. Cleaning up data, especially when I talked about kind of the imagey PDFs where you actually just have like check marks instead of things written out, and you have to like actually say like, is there a check mark in this box? Which is something the computer's not great at. Mechanical Turk is really good at that. The tricky part is, in our experience, Mechanical Turk's biggest weakness is that Mechanical Turk fails if it requires any kind of expertise in your subject area. If you ask someone, is there a check mark in this box? They can say yes or no. If you ask someone the same question but word it slightly differently, did this person vote yes? And there's a column that says like aye and nay, you will get bad results, because a lot of the people that are doing Mechanical Turk, there's a couple things. I don't think English is their first language a lot of the time, and they're not skilled workers. That's a lot of times why they're doing mechanical work. And so a lot of times they're not going to understand. So you have to kind of really break it down into a very simple task, which can be hard. Sometimes that's more work to do than just doing it yourself. Trying to split out, trying to find the checkbox, like the individual checkbox on the page, and showing that to someone instead, in not showing them the entire page and asking who voted which way, can be tricky. But if you have a task that suits itself to that, it's a really neat tool, and you can just kind of upload in bulk tasks, and then you can set a price. It's kind of like a bounty system. I think you can say like, I'm willing to spend up to $100 to get this solved, and then your results come back pretty quickly. People are always working on it.
I had a question about microtagging. Is that something, including attributes within a traditional concept, whether that's something that's starting to take off more and more, and site owners are beginning to expect spread-throughs to?
Yeah,
or
that's
more than just.
So microtagging is a neat concept, and right now so the biggest kind of example of this is some of the schema.org stuff that some of the search engines we're working on together, where you can basically tag all the properties of an event by just kind of adding these tags within a page, or not just an event. I mean, they have like medical devices and things like that, which is weird. I'm not really sure who's tagging medical devices on pages, but events are certainly useful, where you can actually have a search engine pull events out of the page for you and say like, oh, this concert starts at this time. We're seeing a little bit more of that. It's certainly there for people. It is useful for finding contact information. You see more and more of that, because I know that even the advent of like Android and iPhone, by adding a certain tag to phone numbers and things like that on a page, you can make them clickable. Although I think now they can also just be clickable when it detects them. But a lot of people added like telephone tags to pages, which makes it a lot easier to pull a phone number out of a page, or a fax number out of a page. And often to tell the difference between them, because they'll have tagged one as the telephone and one as the fax, and then you can just automate your collection of them when it might not be as obvious otherwise. So we've seen it for that, for pulling out information like people. It seems like placing the burden on content providers like that, well, it certainly would be nice for all of us. I think a lot of times it overestimates the sophistication that they have. Like, I don't think they're really aware of that they're expected to do this. I mean, when someone's running a website on like a 1994 Lotus Note server, it might be a little bit much to ask for them to start adding tags, I think, which is, I think the data that's already good will get better, but I think the data that's bad won't really benefit at all from that.
If they want you to buy something, then
That
page is going to be marked up really well.
Yeah. Google has, so my current project is funded by google.org, which is the nonprofit arm of Google. So we have a little bit of interaction with them through that. And my sense is that Google, which was one of the big advocates of this, has started to realize that it has limited future potential for lots of kinds of data. Like you said, some of them really high potential. I've noticed, I don't know if anyone's booked a flight recently and then gotten an email in their inbox from Gmail, but a lot of airlines have started providing special markups that in Gmail there's a track flight button because they've embedded microtags into the email itself. So stuff like that, they're going crazy with. But some of this other stuff where you really want it, it's not there.
Maybe because of the difficulty of getting it in there in the first place.
Yeah.
Yeah.
Mm-hmm. Questions? All right. Thank you all.
Thanks.